Right, hello there guys, and welcome to another video. And today we're going to be looking at a couple of PS4s. Now, a few weeks ago, you might be aware that I uploaded another video to this channel for pinouts and alternative points for HDMI ports. And if you did damage your motherboard lifting your faulty or broken HDMI port, then you can actually resolder to these alternate points to actually get your machine back up and running again. Which of course is very useful because of course the PS4 only has HDMI out. It's not as if you've got another option. If you ruin that HDMI portion of the PCB, you're stuffed unless you can get it back. So I actually haven't seen one around the net. So I thought it'd be an interesting one to do. And bearing in mind the analytics figures off my channel would suggest it's by far and away the most popular video I have. So hopefully a good few people are finding that sort of stuff useful. So anyway, to cut a long story short, a valued subscriber to my channel, Aussie106, actually got in touch with me about having a look at one of his machines that he'd sent away to a place in Manchester, and unfortunately I didn't know the backstory to this in its entirety. I just thought it was a board with a failed repair, but he's actually left me a note, and I'd like to sort of share bits of this with you. So he says, "Dear Andrew, first of all, would like to say thank you for taking this job on. The complete PS4 console is mine, from new. It fell and had the HDMI port which was damaged. I took it to a repair shop in Manchester and they totally butchered the console. Didn't manage to solder the HDMI port back on properly, so it wasn't making contact with the pads. I didn't realise this, but upon inspecting the console himself, Aussie realised that in fact he'd also tried to replace the Panasonic HDMI encoder IC. And ultimately, you know, that board doesn't work anymore. It does flash pulsating blue light for 10 minutes, restarts to a white light, and then there's nothing further from there. So he's hoping that one's salvageable and not completely dead. The internal speaker's also been damaged by the sounds of it, so we'll see if we can get a replacement sorted for that as well. We've also got another board in there for spares. Going on, he says, hope you can replace the HDMI IC chip and the HDMI port. They've got a motherboard which she bought for replacement parts, with a matching Blu-ray board, which does work, but that's also had issues with the HDMI port, and that's fairly badly damaged as well. So he has very kindly said that I could maybe use the APU and the Blu-ray board for future projects for myself after watching my videos. So cheers mate, that's very much appreciated, and hopefully, as you say, I can use that. Funnily enough, I have got another machine that I could probably use that on, so fingers crossed we can do something for you here. And long story short, I hope you can get at least one of them working. Thanks again, and that's from Aussie106. So I'd like to say thank you to Aussie for this one. And what we'll do is we're going to have a look in the box now, and we'll see if we can see what we've got and see if we can resurrect at least one of these machines for him. So let's go have a look. Right, okay then guys, so this is the package that I've received, and this, I'm just going to open this now. I've pierced the seals on the box there, and remove a bit of this. Now then, from my understanding, there's a complete console in here, which is there, and this will be the donor board, I would imagine. So just pop that to one side for now. Very well packed. It's always a nice thing to see. And so this is the machine in question. So as you can see, one complete PS4, hopefully with an intact HDMI. It looks to be intact from what I can see. Just have a quick look off the camera. Yeah, it should be okay. I think the comb looks a little bit bent, but we'll probably get away with it. So that is that's the PS4 in its entirety there. So we'll break that down and have a look. And we'll plug it in and see what we get. Just going to have a look at the donor board is sent up. So we've got the HDMI encoder IC chip undercover there. It is covered in flux, it has to be said. So they've not even bothered cleaning this off. It's well, somebody's obviously had a go at this board. Oh my god. Right. Yeah, I'll be able to see that, but if you look at those pins at the back, all but 1, 2, 3, 4, 5, 6 of them are completely missing their corresponding pads. You can probably see there's 6 pins in behind that port that's slightly longer. Yeah, they're the ones with the pads. The others are all missing the pads. And the wires there on the bottom side of the board, you can probably see, are absolutely butchered. Yeah, that's... wow, okay, so... yeah, this board may be good for donor parts only, looking at it. But you never know, Fozzie does say it starts up to a white light, so... you know, who knows? Seemingly somebody has actually welded the optical port shut. Oh, I have just managed to loosen it by giving it a quick push, but there is a bit of heat damage on the top. Yeah, so this board has definitely been in the wars, but as I say, this is for parts, so I'm gonna be too bothered. It does have a good speaker there, so we'll see if we can get that replaced, and everything else. Yeah, it's just two through-hole pins there at the back, so that should be easy enough done. It's got an APU on there, which doesn't look to be too badly damaged. Doesn't look like anybody's reworked around that anyway, so that should be good. We've got a NOR flash. We do have a South Bridge chip there. We do have the secondary processor Syscon chip under there. So yeah, so this board should be good for parts. So let's go over to the test setup and see if we can get the PlayStation plugged in, and let's see what it does. So I'll join you in a sec. Right, okay then guys, so we've got the complete assembled PlayStation up before we touch it, so we're just going to see what it does. So the monitor is on, showing no signal. HDMI cord is connected, as is power. So we're just going to try and power this machine on. I don't hear a system speaker. So that is definitely going to need replacing. And this is what he says happens, it just pulses blue light. Now the worry is, of course, is that this does have some other PCB related damage from the attempted repair. But we're just going to have to wait and see when we crack it open, see what's lurking around under the cover, if you like. But apparently it just sits here and does this for about 10 minutes and then eventually reboots to a white light. So anyway, we will have a look and we'll see if we can spot what the damage is. Off camera, what I will do is just try and get it into safe mode and things like that, and just see if there is any sign of life out of this thing at all. And then, like I say, we'll get on to replacing the various bits and pieces. So if you just bear with me guys, and I'll pop the hard drive out and we'll see if we can get it into safe mode. So bear with me a sec and I'll join you in a minute. Okay, so we just popped the outer hard disk bay cover off, and we've popped the screw out of the hard disk caddy, and we're just going to try and get this thing into safe mode. So the system speaker actually does sound, it's just very, very quiet. So anyway, we are going to remove hard drive for now, and we're going to press and hold the power button for 7 seconds, and we should, well, hopefully hear somewhat of a second beep. I did hear a second beep there. We've still got the pulsing blue light. So it did sound as if it was trying to do something there, but the eject button does still sound. Power at this stage appears to be doing nothing. Okay, so it does appear that this machine isn't going to go into safe mode either, so I think what we should do at this point is strip the console down to the board and let's see if we can spot what's going on there. Well, rather unsurprisingly, I don't know what they've done to this machine, but the power supply pins were bent to such an extent I couldn't actually barely get the power supply out. So much so it actually gave me a war wound, so we've already started there. That isn't a Japanese flag bandage, by the way, that's actually blood out of my finger. As you can see, the screw holes are actually split on both ends and the whole thing feels rather creaky. Actual pins in the bottom there are rather bent. And the whole thing looks a bit sorry for itself, so I think at the very least we're going to be replacing this outer case with one that isn't split. Then that way I might actually be able to get it out without shedding any more of my fingers. Yeah, so anyway, we will continue to disassemble the rest of this unit and join me back in a sec when we've got the board out. Right, okay, so we've got our PS4 stripped down to motherboard level now, and my, what an experience. Well, unfortunately, there are a couple of things that I found on this machine. Some pretty bad, others not so. Some of the screws weren't in properly, some of the screws are missing. Some of the screws have actually stripped threads. Some of the thermal transfer pads from the top of the van blocks are missing or absolutely battered up. So those are going to need replacing. And the other quite nice surprise under here is, if you look over the back, we have some very, very nice Captain tape, which has been left on the board, which is a no-no. Yeah, such a shame. Somebody's also tried gluing in the fan connector for some reason. I don't know why, because it doesn't appear to be broken in any way. So let's lift this board out and see what horrors lurk beneath. So I'll just put that there for you. One of the other things we found as well is, and I will see if I can get this for you, but the optical disk drive connector is broken, so you can slide it in, but you can also slide it straight back out without actually having to depress the connector, so they've broken that. So we might have to change that as well. They've slapped a boatload of thermal compound on the GPU, CPU, APU combination. So that should just be the APU, I do apologise. And is there any more? Yes, it looks like we're missing some more thermal transfer pads off the top of these as well. So yeah, it all looks really rather nasty, and we're going to have to see if we can do anything with this. Now, as far as the actual system speaker goes, doesn't look like there's much damage there, but that's not to say the circuit around it isn't. As you can see, it's not melted at all there. The Wi-Fi antenna wasn't plugged in either, so we would have had some very interesting effects with trying to sync DualShock controls and things of that nature, and trying to receive a Wi-Fi reception. So yeah, just generally speaking, it's just not a very happy place to be for this thing at the moment. So let's just have a quick check of this HDMI port. Now by my eyes there's a couple of bridged pins. A couple are broken, some aren't even soldered on. So yeah, that all looks very nice, doesn't it? So that is our missing optical port cover as well, so I'm wondering if the missing capacitor, which we found in the bottom of that bag, is also from this board. So we'll have a look at that later as well. The HDMI encoder IC is looking really rather sorry for itself. A couple of these output filters here are completely missing the tops of their caps because they have had it. And yeah, the soldering job in general just looks really rather nasty and rather poor, particularly if you look around the bottom edge of the IC there. It's all looking really rather nasty. A load of flux and flux residue has been left on the board. It's not been cleaned off at all. Yeah, this is pretty much a nightmare scenario. You know, this is. Oh, I've also put my finger in about a load of thermal paste. But this is sort of what makes me angry with regards to this sort of thing, because, you know, you take it to, I mean, this is sort of with the IT in general, not necessarily games consoles, but, you know, I'm an IT technician by trade, and for a blue chip multi-billion pound international business, and you know, I'm in server side repairs and things like that, and this sort of thing just makes me angry because it's not particularly complicated work, it's not difficult, but unfortunately if you get the wrong person who purports to know what they're doing, you can end up with a situation like this, through no fault of your own. You know, and this needs to stop. But it's such a sad fact that, you know, it's a shame that, I mean, how do you stop it? How do you stop people who are as incompetent as these people have been from doing this to anybody else's machine? And the thing is, if you don't know about these things, you probably won't know any different if they ring you up and say, we couldn't fix it, or there's something else wrong with it. You know, they just pluck out of thin air, and of course you're going to believe it. So that's such a shame. So anyway, we are going to have a look at this board now, and we're going to see if we can get something going on it. So we'll take it upstairs into the workshop, and if you want to join me in a sec, we'll see what we can do. It looks like we found a speaker issue, and if we have a look on the underside of the board, you can see there for some reason somebody's absolutely sodomised that area of the board with a bit of heat, judging by the burnt flux stains underneath it. And if we actually look underneath at board level, we can see there maybe we've got a lovely nice melted speaker. All the internals there are nicely melted into the board, so that's why that sounds like shit. Just generally speaking, really, this board is not very happy. There are solder splashes all over it. You can probably see a couple of bits like that one there by my finger, and some more there by that little transistor, and some more here over the back of there. And yeah, just generally speaking, all this sort of area, including the top of the RAM bricks, is just spattered with solder. So I really don't know what they've been doing with this board, but, you know, either way, it's our job to fix it. So, you know, in a way, I quite like the challenge. I quite enjoy the challenge. I just hope they haven't done anything too silly with this board. So I am going to give it a good look over before we start replacing bits and pieces, because this could quickly become a job where we just chase, you know, mistake after mistake made by the other guys. And we never actually get anywhere with it. So I'm going to give this a very, very careful once over, and then we'll see what we've got to do. So I'm going to make a list of the various bits and pieces we're going to have to fix on this board, and then hopefully we can get to sorting it out. So join me back in a sec. Okay, so it would appear we've quite the list, and these are just the things that I've come across at the moment. So first of all, we need to replace that dodgy melted system speaker. We need to replace the output filters on the base, around the base of the Panasonic HDMI IC. We also need to replace that Panasonic HDMI IC. We need to replace the HDMI port we will clean the board off of the old flux and captain tape residue that's been left by the last place. We'll also remove all the old solder splashes and bridges and everything else that they've left behind them. We will try and repair that optical disc drive connector socket, or replace it should we have any further issues. And then we will also obviously change all that nasty cheap thermal paste and clean the APU off of that mess they've also left behind there. So the first thing is to actually just get this thing cleaned up and see if that actually sorts out the bits and pieces, because we do have bridges and shorts all over this thing. So we will clean this up, so we'll go and we'll take everything off this board now that needs to come off, and we'll clean it up and we'll see if we can get a bit more joy out of the output. So bear with me guys, and come back in a sec and we will go upstairs and we'll get this board ready for rework. Right, okay, so first things first. I haven't actually done anything to this board as yet, apart from give it a bit of a clean up. So we have a look now. The APU is nice and shiny, nice and clean. We've removed the various bits of captain tape stuck around this board. We've given the bottom side a run through, so we've removed all that nasty flux and everything else. We've also picked a fair few solder splashes and balls and everything off here. So, you know, we're starting from not a good place, but better than what we were. So first things first, I could go away and I could replace a load of components on this board to find that I'm still in for a lot of work. And what I don't want to do is get so far down the line that I end up sort of chasing this thing all the way to hell and back. And you know, I don't want to do that. You know, this repair only makes sense if it's feasible. You know, if it's a viable repair. So first things first is, before I go replacing various bits and pieces, I want to see what I can salvage here. So the HDMI port does look to have all its pins intact. It is aligned properly. It's just soldered very badly and they've got bridges in it. So we're going to have to see if we can resolder that, obviously. Now, the comb itself looks okay. We can probably get away with it, to be honest, I think, if we can resolder it properly, but we will see. The underside, the Panasonic MN series chip, again, is, at least it's lined up okay. The soldering on three sides doesn't look too bad, but the bottom edge there is appalling, and the output filters are all going to need replacing because they're all burnt up and horrible. The system speaker, again, is pretty awful as well. That's just 2 points there that you can see, so we can desolder that and replace that really easily. So first things first, I think, is to get you know, the HDMI port and the Panasonic MN series controller chip at least properly soldered and the bridges removed, and then we can at least fire this up and see what it does. See if we've still got a pulsing blue light for 10 minutes, or whether, you know, removing the shorts and the bridges will actually enable these circuits to actually fire up properly and you know, help the machine start up properly. So that's first job. So we're going to resolder this HDMI port properly. So it's into ground. The pins do look to be attaching to the board. They're just really badly soldered. So what we can do is we can resolder those ports. So what do we do with that? Well, that's really quite straightforward. And what we're going to do is we're going to use a technique called drag soldering on the back of this port. Now, what's drag soldering? Well, that is where we give the pins at the back of this HDMI port a really good coating in some flux. Now, don't worry if you know, you can use a lot of flux on this. In fact, to be honest, you want to use a lot of flux on this, because the flux is what's going to help you drag solder. And basically what drag soldering is where you actually get solder on the end of your iron tip and you literally drag it across the points. And the flux should help the solder adhere to the pads, but not to anything else. So you can literally drag your iron across these pins and resolder the connections without doing too much work. It's not an easy skill to master, but it does make your life easier for doing these sorts of things if you can. Now, it's very tight in the back of there and we might have some fun. In which case, then we are going to need a bit of my good friend the desoldering braid. Superb little stuff that, for removing any sort of horrible bits, because let's face it, the soldering on the back of that port is absolutely pants. And then the same for the Panasonic MN series chip on the underside. So what we're going to do is we're going to fire our soldering iron up, and we're going to put a bit of fume extraction on, because let's face it, nobody wants lung cancer. So it might get a bit noisy, but hopefully, like I say, the camera isn't the best setup for this. That is something I'm looking to work on, believe me. As soon as I can afford this, a replacement camera is going to come along. I'm expecting a little one, and various other bits and pieces that I've got at the moment. You know, that's I'll have to wait a little while, so we're going to have to struggle on, but you know, hopefully you can get half an appreciation for this. So it is quite difficult doing it this way actually, because I'm trying to do it further away from me than I would normally do, because I'm trying not to block your view of it. And like I say, it is rather small and fiddly, and it's not the easiest thing to do at the best of times, so do bear with me. So there is a little bit of accumulation of solder at the end, so just bear with me while I try and remove that with a bit of blade. Okay. What I've done there is just run back along each and every pin, just to ensure that they're all nicely tinned and the legs are now touching the board. So there is now quite a bit of burnt flux residue on there, as you'd probably expect, so we're going to clean that off with a bit of alcohol. Don't be shy with that stuff either, you know, you can give that a good old sponging. Okay. Now then, what I'm going to do, I'm going to dab that off with a paper towel. So I'm just going to remove it from the viewfinder of the camera a moment while I just have a look at this closer up. Okay, now that HDMI port, I'm just going to remove it from the tripod. Hopefully you can see this. I'm going to zoom you back out. But hopefully you can see through the viewfinder of the camera. It's not immediately obvious to me, but hopefully when we get this on full resolution on the actual computer, this will become more obvious. But those pins now look nicely soldered. They're nice and clean and shiny. There's no bridges in there, so that's all looking really rather nice. So what we need to do now is rinse and repeat at the other side of this board. But before I do that, I'm going to do something called the pin waggle test on these HDMI port pins. And what the pin waggle test does is it's literally a case of getting the tweezer or the fine point of a screwdriver or whatever you've got. It's got a fairly fine point on it. Touching the end of the pin and just giving it a little wiggle and seeing if it moves. If it moves, it's not soldered to the pad. You need to go over that point again. If it doesn't move, you're good and it's attached. So we're just going to go through each of the 19 pins on the back of this HDMI port and give it a quick wiggle, and hopefully we'll see that we actually have no movement. So again, you might not be able to see much of this, but this is something I do need to be fairly close to the board for. Of course, these pins are really quite small. Nice big accumulation of crap in the corner of this HDMI port as well from the previous solder job. There's all horrible manky flux and everything else from the last guys who didn't bother cleaning it up. It really was amateur hour whoever had a go at this last time. Really was. To be honest, I'm surprised there isn't more damage around this area. I'm surprised I haven't lifted pads. I'm surprised I haven't actually knocked components off. I'm surprised I haven't burnt them. Amazing, but that is looking really nice now. The transformation before and after. Hopefully it comes across on the camera as much as it does actually looking at it, you know, with your eyes. But that's looking really nice now. So hopefully that's going to work. As I say, the cone looks okay. Maybe, yeah, you should get away with that. It should be okay. So what else have we got? Well, we've got this Panasonic MN series controller IC. There are some shorts I can see down this side. So at first glance, the solder job didn't actually look too bad on this chip, but looking at it again, see, the top and left hand sides don't look too bad to eye. So that's this side and this side. But the bottom is atrocious, and this side's got some shorts in it. There is a pin at the top on the left hand side, which looks a little bit suspicious, so we're going to do a little bit of rework on that. There is a point where they've caught that little resistor with a bit of solder. These points here, where it looks like there's a big string of solder or bridges, is fine. That's just where the EMI shield, I have to think about it for a minute there, for where the EMI shield actually sits. So what we'll do is we will just give that a quick once over. Again, we'll use the drag soldering technique on that to actually try and remove those shorts and reconnect those pins as appropriate. Rework that little resistor while we're down there as well. That doesn't look particularly brilliant either. Okay. actually got to dab too much on there, so. It is just to run the blade of your iron slowly across the pins. And if you do end up with a bit of an accumulation at the end, and it's easy enough just to go back sorry about that. This camera has a 15-minute recording limitation on each video as well and doesn't think to start itself back up. But anyway, we I don't know how much of that you missed, but we just started drag soldering the right hand side of this HDMI output IC. So pretty much as we did with the HDMI port. We had a little bit of excess on this side, so we just got a bit of braid and just dabbed that off. We've run back over each pin. Basically, you just touch each pin with the end of your iron, put a little bit of downward pressure into the board and stroke it back across and away from the pin. And that will just encourage any solder on the pads to draw up onto the leg and create a nice solid connection on the bottom of your chip. So, as I say, that's the right hand side of that chip done. So we're just going to do the top side of that now. And this is going to be slightly awkward because it's sat on the power pins, and as I say, it is further away from me than I would normally have it, so you guys can see what I'm doing, which isn't going to make this the easiest thing to do, but bear with me. There does look to be a suspicious blob on top of one of these pins. Doesn't seem to want to be moved, so I don't quite know what they've done with it. Have more flux on. See if I can just tease that short away from those two pins. Nearly there, I think. There we go, that's looking a little bit healthier now, so I don't think they were shorted, to be honest, but they didn't look particularly great, so hope my head wasn't blocking your view too much there. Okay, so what we'll do is just give it another dab of alcohol on the back side of there, because a couple of the pins actually looking, as you're looking at it there, that's actually the top side of the chip as we had the board previously. And on the left hand side of that now, looks as though there may not be sufficient solder tinning those first couple of pins, so I'm just going to clean off any old flux residue. So a fairly soft bristled brush and a bit of IPA. And a little bit of a rub. Should be enough to remove any nasty flux residue off there. And we'll just give it a mop down. So looking at that now, those two sides now are looking a hell of a lot better than they were. Just going to give a pin waggle test on those first couple of pins. And those are now nicely connected. I'm just going to go down the opposite side that we've also done. And that's really nice as well. So we've got the opposite two sides now. So as before, good coat of flux, clean the blade of your iron, touch your solder on the end, quite a cool effect actually, because as you run your iron across you will see the flux burn away and the pin actually go really shiny and the solder flow along it as you move along. You only want to go really slowly and you want a tiny little bit on the end of your iron and just drag it across. And as I say, what I like to do is just clean my iron tip again and then just trace the back here along and just stroke down each pin. It just ensures A, each pin's attached, and B, there's a nice even coating of solder along the pad and the leg of the chip, and that there's no bridges there. I'm just going to give that another quick waggle test here. No, I'm not. I'm going to give it a bit of a clean actually. Flux is building up on the edge of my tweezer blade there, which is just stopping me from getting a good look at the pin. So I'm just going to dab off. Yep, all nice. Last one, bottom side. So we're not too bothered if we take those filter caps back out at the bottom, because frankly they are knackered anyway. Okay, so my eye tells me that's looking quite nice. Whether my tweezers tell me the same tale in a second or so though. And as you can see, you know, these techniques are relatively simple. As you can see, they take not long at all. So why can't a supposedly professional workshop master the arts of something simple like drag soldering? It absolutely astounds me. For a DIY novice, maybe not, but for somebody who's supposed to know what they're doing, it's a shock. So I'm going to give that another waggle test. Again, the alcohol seems to have displaced a load of horrible, nasty old tacky flux that was obviously there from the last supposed job, shall we say. Now those pins ain't moving on the back of a bushing, so hopefully when I give these the tweezer test, these are going to look rather nice. Now there are some fine traces going from these Panasonic HDMI encoder ICs down to these output filters. Those look to be intact from my eyes, so it's just a case of just how much damage the last lot I've done. Okay, so I am tempted to actually plug this board back in now and just see if, now we've removed the shorts, whether we actually now get what is called a white light of death. So rather than it sitting there pulsing blue light for, you know, 10 minutes or so and then rebooting and going to a white light, whether we can now just get a white light, but not a lot of anything else. And if we can, then that's a start, because hopefully replacing these output filters will then get us a picture. Yeah. So those are all nice now. Those are all attached. They're all nicely soldered and they're cleaned up. The output filters, the middle two are actually missing the top. The end one looks a little bit broken. This one on this side actually looks okay, but we'll probably end up changing it anyway. And we're just going to do the system speaker while we've got it here. So the best way of removing the old solder is to actually add some new. So what we want is, remember my fume extraction, and we're just going to add a drop of solder to the old connections, so they now look nice and shiny. And then we'll get a bit of desolder braid. To be honest, I don't think I've got the best tip for the job here. Should stop being lazy, to be honest, and go and replace it. Okay. New tip is nicely up to temperature. That's why I absolutely love these cartridge type soldering irons. Changing the tips is just so quick and easy, it's child's play. Just giving both of those the old pin waggle test there, and those now waggle nice and freely, so hopefully we'll turn this over. This speaker, albeit it is melted to the board actually, so this might could be fun. Because the actual plastic has actually melted to the board itself. I don't really want to damage the board. I'm trying to get this out, so just wanting to be a little bit careful. So I can definitely wobble it. It doesn't want to come off. I'm going to have to be a little bit cruel to be kind here. Okay. Okay, so that is both pins now out of there. Okay. So that's those two connection points cleaned up. That's ready to receive our new system speaker. We've got our donor. Just there. Nice dab of flux. So as before, bit of solder. So the old connection. Now this one's an old scrap board, so I'm not too bothered if I ruin the PCB. Trying to get this one out. So those two pins desoldered and our system speaker is just sat there nicely waiting for us. So next job is to get our proper motherboard back in. And this one sat the other way up, so I don't think it really matters which way around these go. Just pop that system speaker back through the holes. I'm just going to hold it flat with my finger. Just going to get a dab of, well actually first things first, I'm going to change the tip on my iron back. To the original one. Going to get a dab of solder on it. Just use the touch of that to clean the tip. And now I've got a dab of solder on the end of my iron, and I'm just going to support the old system speaker. Okay, we've got it tacked in one side. Just going to add a little bit of solder now. To both connections. And there we go. So, barring the output filters, we should have. I'm just going to give the system speaker connection points are going over with this IPA. Just to remove the old flux residue. They're looking nice and clean now. Okay, that's looking really nice. So what we're going to do now is I'm going to see now whether this still takes a long time to start or whether this actually now behaves a bit more like what I would hope it would. So hopefully what we'll get now, I'm not saying we're going to get any output because those output capacitors don't look particularly nice. So we may not get any output to the display, but by removing those shorts on the HDMI port and the Panasonic chip, hopefully we're going to get a little bit more in the way of picture. Now, a little bit more in the way of activity. So rather than a pulsing blue light, hopefully we're going to get a nice sort of white light fairly quickly. Whether we get an image or not is debatable. Maybe we will, maybe we won't. If we don't, then it could be a couple of things. It could be the Panasonic MN chip has been blown up, which, let's face it, on the evidence of what we had to work with there, with the sort of solder job that had been done on this board previously, it really wouldn't surprise me if they had actually blown the chip they replaced, because let's face it, it really was that bad a job. So what I'm going to do is I'm just going to pop downstairs now and we're just going to fire this up and we'll see whether we have any change or whether we've still got a bit of a problem. As I say, I've not changed those output capacitors yet, or those output filters should I say. I've not changed those yet, so those may well need replacing, but we'll see if we get any change at the moment, having simply reworked the port on the chip. So bear with me in a sec, guys, and we'll go and have a look. Right, okay, I'm having to film this with a mobile phone because the battery on the other camera is dead for now. But what I've done is I've popped down here and I have had a quick look at this PS4. Now, when I initially popped down to test it, there was still an issue with the buzzer. And what I ended up actually doing was measuring the trace between one of the pins on the buzzer and the back of the resistor it links to, and it wasn't reading too good. So what I've actually done is I've ended up just running a link wire from the leg of the buzzer back to the top of the resistor on the other side of the board, and we now get a bit of a result. So what happens now? So after we've sort of removed the bridges from the HDMI port and resoldered that properly, and we've also removed the bridges from the Panasonic MN series chip and resoldered that properly, we now get the following. We get a beep, which is a good start. So remember, before we used to pulse blue light for 10 minutes, console would restart, and then we get a white light. As you can see now, after a short period, we get a nice white light on our PS4. Not all good news though. No signal. So anyway, at least we're getting there. So what do we need to do now then? So we've got our speaker working eventually, and we've also ended up with a nice white light on our PlayStation without too much fuss. We've got our HDMI port successfully soldered back in and our Panasonic MN series chip back in. So why are we now getting a white light but nothing else? Well, I think the answer to that is really rather simple, and you can see wiggling the port there now gives us no change in result at all. So what is left to do with this? Well, the rest of the repair now revolves around replacing those filter capacitors. If we change those filters over, I think we're going to get a working machine. So that's next on the list. Right, okay then, so since the last time you joined us, we've not done anything too exciting, to be honest. I have just removed these 4 filters from the HDMI assembly there, and all that's left to do now is to replace those 4 filters with 4 new ones. And what I have gone away and done off camera is I have gone and desoldered a new set off a donor board, because again, you know, there's nothing particularly exciting about seeing that. So what I'm going to show you though is how we're going to attach them. So as you can see there, that's our HDMI encoder IC there. That's all soldered up now and looking really rather nice. Everything else is okay. I've put a dab of flux across these 16 pads here, and of course these little filter caps are now going to go back on here where of course they do live. So what I'm going to do is I'm just going to pick the first one up. I'm just going to move it into position. I have tinned these points with a touch of leaded solder. So I'm just going to install them all. I'm trying to do this at an angle actually, so it's quite awkward. And that little bit of heat has just made the flux go slightly tacky, which is what we want, because we want these to hold in position while we actually flow the solder underneath them. Okay, so those are now roughly in position. And one problem we might have here is my air tool isn't particularly well at the moment. And it does seem to be taking a while to actually do any proper work. Now, I have got a new one on order. That's going to be here next week. So for now, we are just going to have to struggle along with this one. You can just about start to see the solder going shiny. Okay, so hopefully those are all soldered on. Going to give them a dab of flux. Now that they are where they are. Just going to give them a this will just encourage them to line up on the pads. And of course this board is fairly warm. So the alcohol will more or less just evaporate off. I'm going to give it one quick dab over with a paper towel. Got the remnants of a top of one of those old filter caps there, I'll get rid of that. Okay, so those are now in position, and we should be okay to try and plug this in now and see if we get a picture on our PlayStation. Okay, so we have our PS4 hooked up to our monitor here, and we're just going to see what we get. So we've replaced those output filters. And of course, as far as the HDMI port and the Panasonic MN series chip goes, we have simply removed the solder bridges from that chip and the HDMI port. We haven't actually replaced anything yet apart from those filters, which were completely ruined, so those are now good. So what we're going to do now is we're just going to see what we get when we plug it in, and hopefully we're going to get at least some progress out of this. So hopefully we're going to get a picture, or at least some sort of output to the display. We have checked the HDMI port for bridges and shorts. We've also ensured that all the pins are soldered to the board. The same has been done for the HDMI IC. The only sort of thing that may happen otherwise is, of course, if we get no output to the display, so if we continue to get no signal, or we end up with a black screen or something like that, then we're going to be looking at replacing that MN series chip. The actual HDMI port itself seems to check out okay. So what we're going to do is we're just going to fire this machine up now. Okay, so we do get output to the display. As you can see, the monitor detects it and switches itself to source HDMI 1, so there is output to that display, as you can see. Or you may not be able to see it actually. Try close these curtains a little bit. You can probably just make out the red glow there is on the monitor, just above that little white pot there. Solid red light means it is receiving an input signal, but of course that input signal is completely black. So that tells us one of two things. That tells us, one, we're making good connection with the HDMI port, as we knew, as we've tested. It also tells us we are receiving output to the HDMI port, which is good, but we're not receiving the output that we want or that we need, which means that we have to start looking now at replacing our Panasonic MN series IC, which of course has already been replaced once by the cowboys that looked at this originally. Luckily enough, we do have a few spare kicking around out of here, which will save me lifting it off that donor board, a bit quicker for me. So, plus these are verified as working good, no chips, so we will next get to replacing this little IC, and we'll see then if we get any change in behaviour from this PlayStation, because hopefully once this is changed over, we're going to get a nice working PS4 again. So join me back in a sec, guys. We'll get this stripped back down and we'll take a look at replacing that IC. We've got our HDMI IC there, so what we're going to do is we are going to pop a bit of heat around this once we've added a little bit of flux. And you want to make sure you get a decent coating of this stuff. Like I said, don't worry, you know, if you think you've got too much, because you can always clean it off later. You want a decent amount, because this is going to help the solder flow. So put that on there. Pop a few extraction on as well. I'm just going to heat the area up around this. Mostly you're just looking for the legs of the chip to go shiny. Now this chip has been attached with leaded solder, so it shouldn't take it long, but on these multi-layer PCBs they do absorb heat quite well, so it's important to make sure you warm the general area up. It just helps the chip absorb the heat, which just makes lifting it a lot easier than it would otherwise be. You just want to keep the heat moving around the chip. The important thing for this is not to rush it. If you rush it, you do run the risk of lifting pads and tracers, and you just give yourself a whole lot more work to do. they're starting to separate there now. We'll get that cleaned up and we'll get our new chip soldered on. So just bear with me guys, and we'll see you in a sec. Okay, so we've removed our old Panasonic MN series chip from our motherboard, and basically all I've done is I've gone around the site with some flux and some new solder, and then I've whipped that off to leave some nice clean pads there. So just having a look at our old chip actually, and bearing in mind they've just replaced this. We look on the underside and there's a nice big hole in it. You know, so this chip had a very short life, so much so it never even worked. So yeah, that's a shame. But we are going to replace that now with a known good one from a unit which we pulled, so we know it's good, we know it works. Yeah, so basically this chip, when we measured it before we removed the solder bridges, we resoldered it, there were 4 or 5 shorts around the edge of this chip. And the way you measure that is to get a multimeter and pop it into continuity mode, and that is basically where you get 2 probes, and when you touch them together they beep. Now the only place you should get that on this chip with 2 adjacent pins are here on this left hand side, as you have the rear of the board facing you. You can't see that, I apologise. There. So basically there's these 2 little pins here which come back to a common set of ears here. So that is, it's pin 1, 2, 3, 4, 5, 6, 7, 8 and 9. Pins 8 and 9 on that right hand side as you have the bottom of the board oriented to you. Those are the only 2 pins that should read next to each other. If you get any more adjacent pins which show continuity like that, then you have bridges and they need to be removed before you fire it up, because if you do have a couple of pins, say power to a ground, then you are going to short the chip out and bad things are going to happen, like you're going to get holes in the backs of your chips, just like that one over there is that we've just removed. So we are going to get this little IC back out the packet. Okie dokie, and that is now there. So we are going to change the tip on our soldering iron actually first off. And then we'll add a dab of flux to our pads. And then I'm just going to give these pads the lightest coating. In a little bit of leaded silver. Don't forget to put the fume extraction back on, of course. Might need to drop more flux on that. Okay, so that's our chipset nicely cleaned up there, so we can now go ahead and start resoldering this chip to the board. So I'm just going to nip off and get some more paper towel, and I will join you guys back here in a sec. So all that's left to do now is reattach our nice shiny new Panasonic HDMI IC to our motherboard again. So we are going to add a few minutes structure in a sec, and first things first, we are just going to add a dab of flux back to these points, of course. Okay, that should be enough. So, taking care to ensure that we orientate our chip the correct way up. Now, and it's fairly important to make sure you get this as lined up as you can. Because if it shifts while you're trying to solder it, you're going to have fun getting the other pads to line up and take to it. So you get it lined up as close to you can on the pads. And just get your iron and tin the first leg to it. And what that will do is, because of the flux, the bit of heat on the end of your tinned iron, and that will encourage the solder to take to it. And as you can see now, that is more or less soldered in position. So then go down to the other side. And you'll notice there now that we are nicely in place there. And just check the alignment of your pins again. Any that do need to sort of shift over, now's the time to adjust and move them before you get too far down the line of soldering this thing in place. But once you're happy everything's good, then just go along each leg and just touch the end of the iron to the tip, and that should encourage the solder to draw up. So that's what we're going to do now. I'm just going to add a bit of fume extraction again here, if I can reach it. Okay, so I've gone around all 4 sides there now, and those are all nicely attached to the board. So what we're going to do now is we're going to go around and we're going to test for any pins which may be shorted together. They look good, but of course we want to test them before we fire this up. So I will test these and then we'll clean it up and we'll show you the finished article. So bear with me a sec, guys, and we'll have a look. Okay, so we've got you off the tripod here to have a closer look at what we've done. So this is the HDMI encoder IC, of course, the MN86471A chip that we've replaced. So that's all looking good. We've replaced those video filters down there. This of course is the system speaker, where we ended up having to remove this ring just here, and actually run a jump wire because this connection was actually shorting out. And that basically is what we've done in a nutshell. We've also gone top side of this board. And we've had a resolder of the HDMI port pins there. So this now, hopefully, should be good to go. So we're going to reassemble it. I'm going to test, and hopefully we're going to get a working board. And then once we've done that, we can clean it properly, reassemble it, and hand it back to its owner, hopefully. So join me in a second, we'll fire it up and see what happens. Okay, so we've still got issues with our PS4. And now we've changed the HDMI encoder IC, we are getting a message on screen saying that the signal is out of range. And sometimes we can get a red screen, other times we get no input on a normal TV. On the monitor, as I say, it tells us that the input is out of range, and we get no picture. So I've been scratching my head a little bit, and I have been sort of thinking, you know, is the IC okay? But it should be, because like I said, these were verified as no good working chips. We've no shorts, we've no bridges. There was a bit of a manky resistor, which looked to be broken, which was here, which we've replaced. So anyway, I have got my sort of fine multimeter probes, which are handmade ones for the time being, handmade with a pair of sewing needles and solder. I do intend getting a nice flute meter with some really fine probes on it, actually, in the not too distant future, but for now these are going to have to do. So anyway, I was measuring out the HDMI circuit, and interestingly enough, I came across something which sort of sparked my interest as to, well, maybe not the problem, but it might not be helping. And that is if we have a look on this board and we measure the second pin. In fact, no, we won't do it from this board, we will do it from my done part board. And my done part board is quite useful because for certain circuits I have sort of prepared them in such a way that I can read them off. So I can quickly compare and contrast, and one of these circuits, luckily, is the HDMI. So if we go from pin 2 of the HDMI, which is here, and that leads to the back side of this little component here. So if we do a continuity trace from there to there, hear that? We get a beep. Now I have read these two components values in diode mode across, and they compare similar spec on both boards, but watch what happens when we get our board to repair and we try measuring pin 2 of that HDMI to the back side of the same component. So we're going from pin 2 again to the back side of that component, and we get nothing, absolutely nothing, and we're just showing infinite resistance on the multimeter, or open line as it would do on others. So basically we are getting no connection on pin 2 from the board. So what we're going to do is we are going to solder a little jump wire across from pin 2 to that point of the board, and we're going to see if that maybe not solves our issue, but see if we can get any progress. So just going to change the tip on my soldering iron there. I'm going to get some wire. Now ideally you want something like enamelled wire or magnet wire or something like that for this sort of stuff, because it is very fine, it is fine work, and if you do have to end up running a couple of these, then you know it can be well, frankly it can be misery if you're having to run 30 strand kynar wire everywhere, because it's quite thick in comparison to most things such as magnet wire and enamelled wire because of the sheathing. You can sort of pick apart bits of maybe desoldering braid and use the strands of copper because they are extremely fine as well. That could work, but for now we're just going to use this little strand of kynar wire. So I'm just going to clean my iron and I'm going to tin the end of that with some solder when I can find what I've done with my solder. Do you know what, I really do need to tidy this desk and clean it down, and that way I might actually be able to find what I'm looking for. Probably should have some fume extraction on as well for this, to be honest, but okay. So we've tinned our wire. We are going to put some fume extraction on. Don't particularly fancy breathing lead fumes in, to be honest. Okay, so I am going to get a dab of flux and I'm going to pop it on the back of our HDMI port. Okay. My apologies if I block the view of the camera here for a sec. It is very fiddly fine work and I do need to be close up for this. So from the second pin, HDMI port, okay. Wire clippers appear to have deserted me. That's not what you need. So, just as a test, because there's no point making this look all nice and pretty if it has no bearing on the result. Of course, if this cues our problem, we can always go back and run some nice, proper enamelled wire and things like that. But for now, we're just trying to get a proof of concept going. It's not ideal, but it's going to have to do. So, a tiny dab of solder on the end of the iron. Okay, so we've run that little link wire there now. And hopefully this time when we test continuity between pin 2 and our multimeter, we're going to get a slightly different result. So pin 2 to there now, as you can see. Pin 2 across, we now get a nice reading across, which is what we should get. Just check for bridges between pin 1, which we don't get. Check pin 3. Pin 3, of course, we get nothing apart from across the other side of the resistor, which I believe is correct. We'll just confirm that. Not that boded low. Honestly. Try again. So, back to our reference board. Pin 3 across the back side of that resistor. Reads. So, what we will do now is, I haven't checked the other pins. I'm not going to check the other pins. I am going to plug this board back in now, and I'm going to see if that gives us a result, and hopefully we're going to get somewhere now. So join me in a second, guys, and we will reassemble this PlayStation and we'll see if we get any output to the display. Okay, so we have the link wire from the second pin of the HDMI port linked up to that little portion of the circuit there that we were missing, and now we're going to see if this works. So we are just going to power this on. I feel like last time we had to keep booting it. It obviously boots to safe mode and we have to pull the lead, so when we plug it back in it seems to realise it was turned on, and the next press it seems to beep. So anyway, we have a blue light. Oh, look at that! There we go. Okay, so it's in German, but we don't really care about that right now. As you can see, we've got a nice white light, and we have safe mode. So we are going to go downstairs and get a controller, plug this in, reinstall the OS, and hopefully we're going to be good. So I think we can call this one fixed. So then, ladies and gents, the battery on my other camera's dead, so we're going to film this from the mobile phone for now. But we are just going to have a recap of what we've done to fix this board, which has been quite a lot in the end. So we'll just take you back around. So of course, if we remember, we had when we first started, a blue light of death. Essentially for 10 minutes the machine would reboot and then reboot to a white light. Of course, throughout that time there was nothing on the display. The display would show no signal, pretty much as it's doing now, and there would be very little signs of life from the machine at all. So of course what we did is, in the end, we didn't have to replace the HDMI port. We managed to salvage the port that was already on there. We just tidied the solder job up there and obviously metered everything out, made sure that it was correct and all well and good and in place. The next thing that we did was we replaced our Panasonic MN series IC because we were having issues with that. Of course, after an initial tidy up, we still weren't getting the results we wanted. We replaced all these 4 video filters out here, of course, because those were absolutely sodomised by the previous so-called technician. Under here, of course, is where our system speaker is, which of course is these 2 pins here. We did have a short on the trace that goes to this top pin, so we ended up removing the ring which connects to the end of that trace to prevent the short from occurring, and then we basically ran a jump wire from the bottom of that pin up to the top side of the board to the back of that little resistor there. You can just see it popping up out of that hole, and then that completed our circuit, and then our buzzer started working nicely, of course after we replaced it, because somebody decided they were going to melt the previous one to the board. Yeah, anyway, so once we'd done that, of course we realised that we still had an issue and we still weren't getting much in the way of output to the display. We were getting a black screen. So then, upon having a look at this, and of course anybody who has been following my videos will know I have done a HDMI pinout tutorial, and anybody who has a look at that will recognise the fact that from pin 2 there we have a link wire which goes down to the back of that little component there. I believe it's a diode, and then what that does is completes the circuit from the second pin of the HDMI port to there. It looks like it goes down to an internal trace which has become burned out, presumably from the previous botched repair attempt, and consequently cut that portion of the circuit off. So we've just had to recreate it there with that little Carnal link wire. So that is all good and can stay there now. And then once we did that, of course, we plugged it in, and as we saw, it all worked really rather nicely. So we are just going to give this a last clean out, and then we're going to reassemble it. And of course, as I say, you should never trust anything that anybody tells you unless you see it working for yourself. So of course I aren't just going to leave you hanging at a safe mode screen. We are going to get this back into the OS at full 1080p resolution, so you can see that what we've done has indeed worked, and this machine is good to fight another day. So I'm currently downloading the very latest update 3.0 to my USB stick, and I'm going to reassemble this, and then I'll join you back here. Again on the phone camera, unfortunately, but there's not a lot I can do about that, because the battery on my TZ7 is, for want of a better word, shagged. So yes, it doesn't seem to hold its charge for very long. So anyway, we will join you back here, and we'll get our OS reinstalled. So bear with me, guys, and I'll get that, and we'll see you in a sec. Okay, so we're all reassembled here now, and we're going to reinstall the operating system on this PlayStation, and we're going to make sure that it all goes in and behaves itself as we would expect it to do. Because as I say, if what I tell you to do doesn't work, you shouldn't be listening to me. So we've plugged everything in here. We're just going to pop the monitor on, and we've got the joypad plugged in to the PlayStation there. Got a USB stick here with the latest version 3.0 firmware. We're going to insert that into the front USB, and we're going to start this up. So this is going to go into safe mode now. Just going to move some bits and pieces so you can get a better view of things that are going on here. Okay, so we have started up in German, interestingly enough. So, not to worry though. So what we're going to do is, I'll just see if I can zoom you in. That should do it. Okay, so have to update version 2.5 or later, which of course we've got version 3 on this USB stick, so we're going to go across to OK and enter. And that is going to go away now and have a little think. So please wait. This is where my German lessons back at school some 12 years ago were coming useful about now. So at this point then what it does is it actually goes through and checksums the downloaded image and actually then prepares the installation files, copies it to disk, and then reboots the machine to install it. So whilst we're waiting for that, we're just going to go back over some of the bits and pieces that we did to this machine. So of course we replaced the system speaker, which as I say had a short on one pin. We had to remove the connection ring through the bottom end of the board and then run a link wire to the top. After we'd replaced the system speaker, so I presume the damage was done by absolutely decimating that area of the board with heat by the previous so-called technician. So anyway, we now have a system speaker that works. We've replaced those 4 little output filters there on the bottom of the end of the board. We replaced the Panasonic HDMI IC. We didn't have to replace the HDMI port in the end. We got away with just cleaning the soldering job up, and then of course had to run that little link wire from the second pin down to the back of that diode to complete the circuit, because at the bottom of the second pin of the HDMI it runs to a couple of little vias which must then go on an internal layer of the board. Looks like that has been taken out again, presumably just by careless rework by the previous place. We cleaned up the board of the old flux and captain tape, and of course any more residue that we put there we got rid of. We removed all the solder splashes and everything that was left by the previous technicians. We did repair the optical disk drive connection socket. That was easy enough. It looks like rather than depressing the socket, the previous place tried to lever it back, so they bent the pin out of position. So that was just a case of putting the cable back in, getting a pair of tweezers and just pushing the connector forwards, which encouraged it to latch on, and that now works okay. So we didn't have to replace that in the end. We just had to bend the locking pin back into place. And we also changed the thermal interface material, so the heatsink compound, and cleaned up the APU. And now we are back at this stage. So as you can see there, it's going to initialise the PlayStation. Do I want to continue? I say yes to that, or yeah in this case. So it's initialising the PlayStation 4 now, it's telling us not to turn it off. So it's now going to update the system software. So yeah, we've actually ended up doing quite a bit of work to this PlayStation to get it back to this point. But as you can see, you know, there's a lot of logic to this sort of thing. So initially we weren't getting any signal at all, and a pulsing blue light for 10 minutes it would reboot to a white light. By removing the solder splashes and cleaning the soldering job up, we managed to get output to the screen, albeit black. We replaced the system speaker, of course, and got that working again. And then, as I say, once we actually replaced the HDMI encoder IC, we then ended up with output to the display, albeit we were told by the display that the input signal was out of range, so we were getting signal, but not in a format that the screen could understand. And then, as I say, once we ran that link wire from the back of the HDMI port 2 to complete the circuit from that internal trace that's obviously been damaged, then obviously we ended up with this result here, and this is where we find ourselves now. So as you can see now, we've reverted to English thankfully. As I say, it's been 12 years ago since my German lessons at school. Albeit I did get an A. I was quite good at it, so but it has been a while. So we're installing the update file now. It tells us not to turn the PS4 off during the installation, which of course we won't do. We're quite happy to let this thing run along and do its thing. So yeah, if you guys have any similar sort of experiences of these things, any sort of repairs from hell you've done, or any sort of repairs from hell you're aware somebody's had to do to your machines because of, you know, either mistakes that you've made or mistakes that other sort of technicians have made, then, you know, drop them down in the comments. They're always interesting to see and read. But it does interest me actually, because obviously in this instance it's hard to say because of the mistreatment of the machine by the previous technicians, but there are tales of white light of death consoles where people have replaced HDMI ports and the ICs and they've still ended up with no output. I'm wondering whether the previous technician has damaged that internal trace from pin 2, or whether the Panasonic IC actually ends up taking that trace out when it burns, maybe on certain occasions. So it's an interesting one. It's probably one to take note of in future, certainly for myself, if we get any more of these. Yeah, it's certainly an interesting idea as to whether that has something to do with some of those perpetual white light of death issues. Having not been able to get my hands on one, I'm not aware of that. The one white light of death machine I do have was fixed relatively easily just by replacing a HDMI port. And funnily enough, my air tool isn't particularly well at the moment, so my new one is on the way. So it did sort of make doing this work a little bit harder than it would normally be. But we got through it in the end, and so we're just going to reboot now. So the firmware upgrade has run through. And the console is just restarting now. So yeah, this latest firmware upgrade is version 3.0. Okay, so it looks like it's run through the full initialisation. There we go. So we're going to sync this controller up, and we're just going to run through this very quickly. I'm not bothered about hooking it up to my Wi-Fi connection. Don't particularly care about the date and time for the time being. And there we go. So as you can see, we have a 1080p display here, and it is showing up lovely jubbly. There are no artifacts on the screen, there are no pixels, any snow on there, there's no lines across it. It looks really quite beautiful. So that to me looks good. So we're going to unplug the USB stick, and we're just going to insert a game just to make sure that this works. Should do. But as I say, I like to prove that what we do here works in its entirety, and of course with a PlayStation that means being able to play a game on it. Okay, let's start. Of course I will reinitialise this machine before it goes back to the customer, so they can fiddle with this to their heart's content. And there we are. So that's FIFA, and that's our PS4. ladies and gentlemen, is us done here, and as I say, I think we can quite happily call that fixed now. And so what I will do is I will see you on the next vid. Like I say, if you like what we've done here, please comment, rate, subscribe. And as I say, I owe you guys a massive thank you. The videos really do seem to be taking off at the moment. I am gathering, you know, a reasonable number of subscribers, which I'm really pleased about. And as I say, it makes me feel like I'm doing something worthwhile for you. So anything you'd like to see, or anything you've particularly enjoyed, as I say, drop me a message. And as I say, guys, I will see you on the next video. So thanks for watching. You've been brilliant, and this PlayStation's been a nightmare, but but we got there in the end. So I will see you later, and goodbye.